Hi y'all, I am Misty Perry, and this time we're going to do prime factorization and least common multiple. So there's two ways to do it, really, my prime factorization. One is a tree, it's kind of an upside down tree, and the other is to make a list. They're both very similar. So with the tree, you're going to figure out what two numbers go into this. And if it's an even number, I always start with 2. And, oops, okay, 1050 divided by 2. And that gives me 2 times 525. 2 is prime, so I'm going to circle it. That one's done. Okay, I know that 25 will go into 500 and 25 goes into 25, obviously. So I'm going to go ahead and divide by 25. Okay, so that is 21 times 25. Neither one of these is prime, so I keep going. 21 is 3 times 7. 25 is 5 times 5. Okay, 3 is prime, 7 is prime, 5 is prime, 5 is prime. So those are the prime factors. And when you go to write this, you have a 2. So you go 2 times, you have 1 3 times, you have 2 5s. So you put your square here times 7. And that's your prime factorization of this. Okay, the other way is to make a list. Very similar. So I would do the same thing. I would go 2 times 525. The 2 is prime, so I'm going to leave that there. 2 times 25 times, and we already figured this out over here, 21. This is still prime, those are not. 2 times, I'm going to break this one down, is 5 times 5. Okay, so prime, 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 not. So I'm going to keep breaking numbers down into their factors until I come all prime on my list. So again, you have 1 2 times, you have 1 3 times, I have 2 5s, so that's 5 squared, times 7. You not have to put them in order, I just do that for the purpose of the least common multiple. It's just easier to see what you're doing, and one of the methods I use for least common multiple, you kind of need them in order to make it easier. Okay, so the tree and the list are pretty much the same. Yeah, okay. Least common multiple. I'm gonna erase this over here. So I have room. I want to find the least common multiple of let's go 18 and 24. Okay, so one way to do this is to list the multiples. So 18 times 2 is 36. Oops. 18 times 3, 54. 18 times 4, 72. And you just keep listing multiples until you come up with ones that match. 24 times 3, 72. There we go. Once you have a set that matches, you're done. Now, people ask me, well, how did you know to stop at 72? I didn't. I just took a guess. I do the top one for a little while, and then I'll do the bottom one, and if I have no match, I'll continue the top one, continue the bottom one. So I didn't stop at 72 because I happen to know that's the thing. Okay, so that's least common multiple. The other way, the way I like to do it, is you're going to use the prime factors. So if I break 18 down into its prime factors, that's going to be 2 times 9, and 9 is 3 times 3. Okay. 24, if I do 24, that is 3 times 8. And then 8 is 2 times 4. 4 is 2 times 2. So now what you do is you take out everything that's common. I have a 2 and a 2. I have a 3 and a 3. Oops, I forgot my times there. Okay, now everything that's left you multiply together. 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. I think I did something wrong. That's the least common factor. That's the greatest common factor? Oh, right. I got it now. I don't cancel them. That's the greatest common factor. I don't cancel them. I'm going to only write them once. So that's a 2 times 3. And then all the leftover ones. There we go. Now, when I multiply these together, that will give me 72. A little confused in the middle there. I got there. Okay, so let me erase this and go again so you can see what I did. So 18 is 2 times 3 times 3. Whoops. My goodness, now I'm all screwed up. Times 3. And 24 is 3 times 8, which is 2 times 2 times 2. This is why I was saying I like to write them in order earlier, because then you can line them up a little better. But I have a set of 2's, and I have a set of 3's. So when I have a set, I'm only going to write it down once. So that takes care of those. I have a set of 3's. That takes care of those. Now I'm going to put everything that's left over. And when I multiply all that together, I'm going to get 72, which is what we found up here. Okay, I hope that made better sense. So, why do we need the least common multiple? To do fractions, right? Okay, so I have this little check sheet here that I always use. This is my personal, this is what I do every time. First, I look, see if the small number goes into the big number. If it does, use the big number. If that's no, I look, are is one or both of them prime? Because if they're prime, you're going to have to cross multiply, which in this case would give us, that would give us 5/15 plus 3/15, because I multiply across this way. Gives me 15 on the bottom. If no, then I go to least common multiple. Okay? You can cross multiply all fractions, but then you have to simplify at the end. If you find the least common multiple, it's less likely that you have to simplify when you get done. So, for example, if I have 3/6 plus 1/8. Okay? Three 6 plus 1/8. So I know 6 is 2 times 3. 8 is 2 times 2 times 2. I have a set of 2's. So I'm only going to write that down once. Then I have the 3 and 2 2's left together. We figured out just a little bit ago that 2 times 3 times 2 times 2 equals 24. So I know that the least common multiple is going to be 24. Okay, so 8 times 3 is 24. So you're going to multiply this side times 3. 6 times 4 is 24. So you're going to multiply this side times 4. Then you can add. Okay. Sorry that was confusing in the middle. Wish I knew how to edit. So let me know if you have any questions, and I'll see you next time.